Hey guys, in this tutorial we're going to learn about some basic rigid body physics. What I'm going to do is I'm going to construct a rocket from scratch, and we're going to assign some physics values to that rocket, and then we're going to launch it using something called initial force. So to get started, let's actually go ahead and construct our rocket. We're going to construct that from some basic 3D blocks we can find in our props folders here, the props section, props folder, and 3D blocks. We should have some down here. There we go. And let's go ahead and select cone. This is going to be the tip of our rocket here. I'll just bring that in and raise it up a little bit, and then we'll go down to our cylinder right here. We'll just add a body for our rocket here, and we'll just zoom out a little bit so we can see both of those. You bring that cylinder up, and then we have a bottom section for my cylinder as well. So I'm just going to double click another one, create another cylinder, and what I want to do now is kind of scale these down. So I'm going to press the R hotkey to bring up my scale gizmo. Scale that down a little bit, and let's bring the midsection up there a little bit. I think that's okay. It's going through the cone, but we're going to adjust that in just a moment. And let's take our other cylinder right here and use our hotkey and scale that down as well, and make that even skinnier. And let's just bring that up right there. Okay, I think that looks like a fine and dandy rocket, except this part needs to be raised as well. Select that cone. There we go. Alright, so there's our rocket. Now, keep in mind that when you're creating physics objects, rigid body physics objects from scratch, by combining primitive shapes like I'm doing here, you want to make sure that none of those meshes are intersecting. And the reason for that is that as soon as you activate any sort of force on them, they're going to force apart because their meshes are kind of forcing away from each other. So you want to make sure they're nice and cozy right up next to each other. And the way to do that is use the snap to model function. A cool little function I like to call snap to model. So to get to that, you can press Control M, or you can press Control P and go into your preferences, and we have snap to model right here. So this will allow us to move an object to another model really quickly. So I'm just going to go here and close that down. I'm going to select my little midsection, and zoop, you can see it snaps right up to that triangle, or rather the cone there. And let's take the bottom section here and snap that up to the middle section. And then what I can do is I'll just press Control. We'll take off the snap to model now. You can see I want to align these all together in the correct way. They align in a kind of a weird way. So I can actually just select them all, Control and click each one of them, and I can go to Align up here, Align Object, and align them on the x-axis and the y-axis. And then we have a perfectly symmetrical rocket going on here. We don't want to align them on the z-axis because it'll look like that. So let's go ahead and keep it this way right here. And then I'll take this bottom section here, and I'm just going to move this bottom section maybe a little bit over to the side. There we go. And there's our rocket. And let's go ahead and take a look in the scene manager right now. You can see we have 3 separate objects. But what I want to do is attach these together. But before I do, I'm going to just quickly assign some material values to them. The top, you can go down to your material settings here. We'll choose a diffuse color, maybe nice kind of maroon or red, whatever that is there. And the middle section, go to your diffuse color in the material section, material settings, and we can set this one to a nice blue. All right, that looks a little bit better than just staring at a plain white rocket. So to continue on, what we need to do is attach each section to each other. So each section to the other one, actually. So we're going to create a hierarchy. And the easiest way to do that is just right-click on your object and select Attach, and attach to the other object. So now you can see the cone is a child of the cylinder. And if I select them, the selection box is a little bit bigger. And the other way you can do it, if you can go over here to the properties in the modified panel, and you go all the way down to attach, and you can select pick parent, and you can pick that parent right there. And now we have the 3-level hierarchy for our rocket right there. So we actually want to merge all these together now into a single mesh. Since we have no use for them to be apart, let's go up to Edit and Merge. And then they merge into one single object. So we have this rocket. Our rocket's ready to go. That's about it for constructing the rocket. Let's assign some physics values to this rocket now. So I'm going to go over here to the Physics tab, and you can see everything is currently disabled because we have not activated the physics. So let's go ahead and activate that. And now we have this kind of cool looking bounding box in the red wireframe around our rocket. So what does this bounding box do? Well, let's find out. Let's press play. And you can see it doesn't do much right now. It just kind of falls through the floor because we have nothing to prevent this rocket from falling through the floor. So to do that, to prevent something from falling through the floor, we need an infinite plane. So I'm going to go over to the Content tab here, and in our Props folder, we have a folder called Physics Objects, Physics Props. There we go. So double click on that. And then at the bottom here, we have this infinite plane. So it sounds really powerful, and it is. We're going to just double click this, and it's going to create an infinite plane along my grid here where nothing can pass because it has the power of infinite physics. It just stops things from going through the ground, basically. So let's go ahead and take this prop right here now, and we'll play back. And boom, it just kind of lands straight, which is kind of weird because it's lopsided, and it looks physically impossible to be able to do that. And that's because we have the bounding box set to this big rectangle. So if you plop a rectangle on the ground, directly on the ground, it'll just kind of, plop there and stay there. So let's go ahead and add some variety to this bounding box. So to find the bounding box, you want to go down here to Bounding in your Bounding section. And you can see the type is currently set as box. So let's change from box to sphere. Oh, that doesn't look good, so we probably want to choose a different shape. Capsule doesn't look much better. Convex hull is actually pretty good. It's for use with if you don't have to be super accurate in your collisions, you can use convex hull shapes. You can see if I press play, now my rocket will kind of just slide over, and that's fine right there. And notice that when my rocket kind of falls, it kind of slides as if the center of mass is kind of right here. And that takes us to our next section, which is called center of mass. So what I can do right here is I can actually edit the offset of my center of mass. You can see it's currently right there. What if I wanted my center of mass to be a little bit lower, maybe down here? Let's go ahead and try that. And if I play back now, you can see it takes a bit longer to fall over because our center of mass is set to over here, which isn't really too accurate. So let's go ahead and set that back to the default center again and put it into the middle there. I don't know if that's completely accurate either, but that's what we're going to run with right now. I'm not a physicist, so let's just move past it. We'll change the edit offset, take that off rather. And what I want to actually do is align this to the floor too. And let's change the mesh from, or the bounding mesh from convex hull to self mesh, which is a much more accurate mesh right here, although a little bit higher demand on system resources. I want to align this to my my infinite plane on the bottom there so it stops falling, because we're going to launch it from the ground. So the way I can do that is select it and select Align To, and then go into my scene and just select my infinite plane. And we want to align it on the z-axis. So there it's just resting along the z-axis right there. And there we go. There we have our nice object kind of just sitting on the z-plane. It's slowly falling because the center of mass is kind of still up here. So what I want to do is let's go ahead and create some initial force. And the initial force is down here at the bottom. And we have the move, the rotate values right here that we can adjust. And keep in mind that these values will go according to your world axis. Now, I'd like to explain world axis versus local axis. So let's go ahead and take a little gander in here. You can see that the scene root right here has a red line, a green line, and a blue line, as does my prop. They are currently both on the world axis. But if I use the E hotkey and I rotate my prop, maybe about here, and I press the W hotkey, you can see it still has the world axis, but if I press W one more time, it'll switch over to its local axis. And that means it's this local props axis right here, as opposed to the world axis. This doesn't matter when it comes to your initial force, so what we can just do is press Ctrl Z, undo that, bring it back to its original position. Just keep in mind that initial force goes according to the world axis. So let's go ahead now and assign an initial force. We want this rocket to kind of shoot off in the direction going left. So you can see the x-axis is pointing to our right here. So we need to assign a value of maybe negative 200 to our x-axis, which means it'll go this way instead of this way. So negative, away from the line there. So you can see, boom, we press play. That's our initial force. we have this initial force of 200 on our rocket. So that's kind of cool, but rockets were meant for launching, obviously. So let's go ahead and try and launch this bad boy. Let's actually add some strength onto the z-axis. Maybe about 1,000, I think, should do. And we'll go ahead and press play one more time. And you can see our rocket will launch. Boom. Looks pretty cool. But maybe we need to add some rotation value to that as well. So let's take a look at which axis we want it to rotate along. We probably want it to rotate around the green axis, which is the y-axis, right here. So let's select a rotate value, maybe something like 25. Whoops, that would be way too much, 25. And let's see what happens when I press play. Let's see exactly how much rotation that adds. Whoa, that's a lot of rotation, and this thing kind of bounces off into infinity. So let's go ahead and change this rotate value. First of all, to negative, because we want it to go this way. And second of all, we need a much lower value. So let's try something like -1 and press play and see what happens there. That looks a bit better. That looks a bit more natural. So let's go ahead and maybe even increase that a little bit to -1.5. And we'll zoom back a little bit and try that one more time. There you go. I like that, but it's really not enough motion on enough force on the x-axis for me. So let's try negative maybe 350 and press play. There we go. So we have that that rocket launching pretty nicely there, and maybe even -1. Let's give it a little bit more force on the x-axis. We want it to land right on its nose. So let's go ahead and press play. There you go. That's kind of cool. Maybe -1.2. Let's try and make this thing land directly on its nose. Okay, good enough. So we have our first rocket. So that's kind of cool. We have initial force. But what if I want my initial force to happen at a later location or a later time frame in my project? Let's create a couple of rockets now. And I'm going to do that by holding the control key and clicking and dragging on this rocket to create another copy. And we'll create another one over here. And so this one has all the same physics values assigned. That copies along with it. I'm going to create a third one. Hold control and copy one more time. Let's move this one over here. So now we have 3 rockets. If I press play, they'll all launch at the same time and all land exactly the same. But what if I want them to launch at different times? Well, rockets will only, or rather objects, physics objects will only launch when they're assigned a dynamic physics state. So if we go up here, let's take a look at these physics types. We have dynamic, kinematic, static, and frozen. So a brief explanation of these. Dynamic physics objects will be affected by any other physics objects, even gravity. So right off the bat, they'll fall. If they're hit by other physics objects, they'll fly off. It's really the wimpiest, physics property. And then we have frozen. So frozen will stay in place until another object interacts with it. So it'll basically stay frozen until something hits it. Kinematic is the physics state we use for stuff that we control. So if you have a ball moving along a path or something like that, obviously you can't use dynamic physics because it wouldn't move along the path. So you have to use a kinematic state, which means you can control it, but it still contains physics. The static state here is basically used for walls and floors and stuff like that, like your infinite plane here. It is the most powerful state, and it won't change. And then, of course, we have all these values down here: mass, friction, damping, elasticity. And these ones here, we're not going to go into these in this tutorial. You can kind of look those up, but we'll go into them in another separate tutorial here. So the original point here was to actually get to launching the rockets at different times. So first of all, what I need to do is I need to actually go up here and remove rigid body simulation. So once I do that, if I press play, these will actually still launch because they contain physics animations. For example, if I select this rocket right here and I press F3 to go into my timeline, you can see my cylinder is selected. And if we go into animation, you can see there is a physics animation clip in the animation track right there. And that's the animation that we have. If I right click on that and remove object animation, that clip will be removed. And only these ones will shoot off now. So let's go ahead and select all of those. Right click and remove animation. from this one, right click remove object animation from this one. So we want this one to launch at frame 1. That'll be fine the way it is. Let's just turn on our rigid body simulation for now. And let's take the second one, and at frame 1 we want to assign it as frozen. So I'm going to press F3 one more time and go into my timeline with this object selected, and just scroll down here. And we can see we have a track called rigid state, and currently it's set at dynamic. But let's go ahead and set this to frozen at frame 1, and then I'm going to move over to about frame 30, and I'm going to set this one to dynamic. And you can see it adds a keyframe there in our rigid state track. So at first, it's frozen from here to here, and then when it hits here, it becomes dynamic. And that's going to create a kind of a cool effect, which I'll show you in a moment. Basically, it's going to launch at frame 30, just to kind of spoil it for you. Let's take our third one here, and let's do the same thing. Let's change this one to frozen at frame 1, and then this one will go to frame 60, and change it to dynamic. We scroll down, we can see our rigid state right there. Now let's close this down. And so with rigid body simulation set on, let's press play, and we see our 3 rockets launch at different times. Alright, so there we go. Let's just take a look at that one more time. Get a good view of it right here. There we go. That's a beauty. Alright, so there we have our 3 rockets launching at separate times. And that's basically how you use initial force. You can combine that with adjusting your physics states, and you can even mess around with the properties, your mass and friction and all that stuff. Make sure your bounding mesh is accurate for the kind of effect you're going for. And of course, you can also make sure your center of mass is changed as well. Let's see if we take this one here, and we decide to change this center of mass to something a little bit lower, and take this one and assign this one super low, like that. Turn off the edit offset. This one. There we go. Let's see what happens when we assign these different centers of mass, just to see the different effects that they have. You can see this one kind of moves around a little bit strange, but that's about it. So when you're using center of mass, go for different effects according to the shape of your object. I think these ones, center of mass might be somewhere around there. I have no idea. But anyways, that's about it for teaching you about rigid body physics simulations. In addition to that, you can also change from real time to by frame mode if you want more accurate results for your physics simulations. I was using real time mode there. By frame mode normally goes a little bit slower, but normally has a little bit more accurate results when it comes to especially soft body, soft cloth and stuff like that. So that's about it for the rigid body introduction tutorial. Thanks for watching, guys, and make sure you check out our other tutorials on rigid body physics as well.